So the first problem in superposition, we need to find the current I8. So here the circuit has two current sources, one current source and one voltage source. So first we need to switch off the 6 amp source, then we keep the 2 volts on, then we switch on 6 amp source and we switch off the 2 voltage source. So here we will get the two component of I will be I2, I8. I8 dash will equal 6. We apply current divider, so 6 times 3 over 11. So it equal 18 over 11 amp. In the second, 8 double dash, the voltage source is on and the current source is open circuit. So I8 will equal 2 times over 11. So I8 will equal I8 dash plus I8 double dash, which is equal 20 over 11 amp. The second problem, we need to find I using superposition. It's straightforward as the first one. So exactly the same. We have two sources. So I will just write the final answer. So I will equal 7 amp. I dash will equal 10 times 9 over 13 amp. I double dash will equal 1 over 13 amp. So if we add this together, then I actually will equal I double dash. In the third problem, we need to find V1, or we need to find the individual contribution of each current source to V1. So from this circuit, you have two voltage sources, two current sources. Each one of them will contribute to V1 and V2. So here we will apply the current and voltage division. So for the first case, the current source will be here, then this will be the 1 ohm resistor, and here the 5 ohm resistor, and here this will become 7 ohm. So this one V1 double dash, and here this V1 double dash. Here the 7 amp current source. So we can find the current with the current divider. We can find V1 dash. So V1 dash will equal 7 times, we multiply by the other resistor, which is 5 plus 7, 12 over 13. So this is the current, then the current will be multiplied by the 1 ohm resistor. So this will equal 84 over 13 volt. In the second case, we switch this off and we keep the 4 amp resistor on. So this is 5 ohm. This is the 1 ohm. Then here, this becomes the 7 ohm. Now Note that the 5 and 1 now become in series because this source does not exist. And this is for now also we need to find the V1 double dash. Note that the current will cause a positive voltage here, so V1 dash becomes negative. So V1 dash double dash will equal minus 4 because the positive here. Yes, this is why we say it. So negative 4 times 7 over 7 plus 5 plus 1. So it will be 30. So this becomes minus 28 over 13 times 1 because we have the resistor here 1. So V1 will equal V1 dash plus V1 double dash. So this will equal, notice the negative sign, so it becomes 56 over 13. So will equal 0.08 volt. The fourth problem, we have one voltage source, one current source, and we have dependent current source. So remember that superposition applies only for the dependent sources. So here we switch 1 volt on and the 2 amp off. So here we will have 1 volt, then this is 5K, this is 7K. Remember the IX is here, so minus negative 0.2 IX, and here this is the 7K. This is the 7K. So we need to find now IX. So here we remove that 2 amp source because now it becomes open circuit. So here we can apply any technique. So this becomes IX double dash. We can use nodal analysis or mesh analysis to reach to IX. So here we say IX dash double dash will equal 0.0339 milliamp. For the second case, this becomes short circuit. So here we will have 5K in series with the 7K. So this is 5K. This becomes the 7K, and we still have IX here. This becomes minus negative 0.2 IX. Then this becomes 2K, and this is the current 2 amp. So from here we will find the IX double dash. So IX double dash will equal minus, it will equal 0.339. So the total current will be 0.339. You need to find out how we reach to this. So 0.339. So the current here, actually IX dash will be double dash will be in milliamp. So it will be something in milliamp. We move to problem number 5. So in problem number 5, we need to find the individual contribution from each source to the voltage V. This is the voltage V, and we have two sources, the 6 amp and the 4 volt. So this is should be 4 volt, not 4 amp. So then we need to find the power absorbed by the 2 ohm resistor. So we find V, then we find the resistor, the power that is based in the resistor. Remember here you have a dependent source, 0.4 I1, and this is I1, the current that is flowing in the 2 amp resistor, in the 2 ohm resistor. So here in the first case, when we have only the 4 volt source here, only the 4 borders, so this will not exist. So our circuit becomes our circuit becomes like this. So 7 ohm, 7 ohm, then this 1 ohm, then there is no current source here. So here this is the 2 ohm. 2 ohm, and this is I, and here we have the 3 ohm resistor, and this is V, and we have here the dependent source. We have here the dependent source 0.4 I1. So we can just write nodal equation for this circuit. So we call this 1 and we call this 2. So V1 minus 4 over 7. V1 minus 4 over 7, the current here. The current in this resistor is just V1 over 2. The current in this resistor is V1 minus V2 over 1 equal 0. So this is, we call it 2 and we call this 1. Then from this we can simplify this equation to V1 minus 7, V2 equal 4. In this node we have V2 over 3, V2 over 3 plus V2 minus V1 over 1. V2, and we have the current source equal 0.4 I1. Now we have this dependent current source. We need to get rid of this independent current source. So from the circuit, I1 equal V1 times 2. I1 equal V1 times 2. So we can say that it's equal 0.4 V1 over 2. So we will have these two equations after we simplify 1 and 2. So 1 becomes minus 7 V2 equal 4. 2 will equal plus 4, V2 equal 0. After these two equations are solved, we get V1 and V2. V1 and V2. V2 will equal 687. So the final answer, I will get the final answer for V1 and V2. So V2 will equal V2 dash plus V2 double dash, it should equal 3.375 volts. And the power dissipated in the 2 ohm resistor will equal V1 squared over 4. V1 will equal minus 1.25. Square over 2, so the power dissipated 781 watt.